Hello students, welcome to lecture 3. Today we will discuss domain and range of a relation. So let R be a relation from set A to set B, then R is a relation from A to B, and R is defined by the set of all ordered pairs of the form A comma B, where A belongs to set A and B belongs to set B. Now this A is the first component of this ordered pair, and this B is the second component of the ordered pair. So the collection of all such A's means the set of all first components of the ordered pair AB in R is called the domain of the relation R. Is called the domain of the relation R. I am highlighting this also. The set of all first components of the ordered pair AB is called the domain of the relation R. Means domain of R will contain all those elements from set A only, right? As A here belongs to the capital A. So if you define a relation R from A to B, so your domain will be set A, right? Here domain of R is a subset of A. This we will explain later on, but for now you may assume that domain of R equals to A. Similarly, the set of all second components of the ordered pair AB is called the range of the relation R. So range of R contains the collection of all those second components of the ordered pair AB such that this B belongs to the set B, right? Let us understand this by an example. Suppose I take this example, right? Let A equals to 1, 3, 5 and 7 and B equals to 2, 4, 6 and 8. Now let us define a relation R from A to B, right? This R from A to B as 1, 8, 3, 6, 5, 2 and 1, 4. You may clearly see that the first elements over here are 1, 3, 5 and 1. 1, 3, 5 and again 1. This first component belong to set A, and this second component 8, 6, 2 and 4. See here, 8, 6, 2 and 4 belong to set B. So R is a subset of A cross B. So R is a relation from set A to set B. We denoted by R is a relation from set A to set B. Now we need to find the domain of R and the range of R, right? So how to find the domain of R and the range of R? Now by definition of domain of R contains set of all first components of the ordered pair. Here set of all first components is 1, 3, 5 and 1. 1, 3, 5, right? As you can see here, the domain of R is what? 1, 3 and 5, but set A is what? Set A is 1, 3, 5, 7, means set A contains an extra 7 which is not present in the domain of R, but but every element of domain of R is present in set A. So domain of R is a subset of A. This thing, domain of R is a subset of A. That's why we have wrote over there. Let me check. Yes, this thing, domain of R is a subset of A, right? I hope this is clear now. Next, so this is our domain of R in this question. Similarly, what is range of R? Now, a range of R is the set of all second components of the ordered pair. Means if AB belongs to R, then the collection of all those B in set B, right? So here all these second components are what? Second components are 8, 6, 2 and 4. See, 8, 6, 2 and 4. Again you may see here that your set B was what? Set B was 2, 4, 6, 8, 10 and your range of R is what? Range of R is 2, 4, 6, 8. So clearly range of R is contained in set B, or all the elements of range of R is in set B. Set B contains an extra element 10 over here. That's why we have written here that range of R is this, which is a subset of set B, right? Now another term that you will encounter is codomain of R. What is this codomain of R? If we define a relation R from A to B, we know this set A is called the domain, or domain is a subset of A, and this B is called the codomain. Range is subset of codomain, right? Okay, we have seen this, that a domain of R is a subset of A. Similarly, you can see this range of R is a subset of codomain. Here codomain is set B, means range of R is a subset of set B. I hope this is clear to you. Codomain of R is set B itself, which contains this element. From here you can see that range of R is a subset of codomain of R. Why? Because range of R contains 2, 4, 6, 8 and codomain also contains 2, 4, 6, 8 and an extra element 10. So range of R over here is contained in, or is a subset of codomain of R. I hope this is clear. Now we see another example, right? Let A equals to 1357 and B equals to 2468 be two non-empty sets. We define R equals to all those ordered pair x, y such that x is greater than y. Here we have set a condition, right, that all those ordered pairs of the form x, y will belong to R if and only if the first component is greater than the second component. Here we are supposed to write R as a set of ordered pairs and also find the domain and range of R. Now see over here. R is basically the set of all ordered pairs of the form xy where the first component must be greater than the second component. We start from 1. We start from 1. This is your arrow diagram, right? This is your set A, this is your set B, and R is a relation from set A to set B. Now check for 1. If we want to check for 1, we take the first pair 1 2. Does 1 2 belongs to R? Obviously no. Why? As 1 is less than 2, so this condition fails. Greater than condition fails, so we discard this. Second, does 1 comma 4 is possible? No. Why? As 1 is less than 4. Again this condition fails. X greater than y condition fails. So we cannot take these two mappings, right? Next, we check for 3. Is 3 comma 2 possible? Is 3 comma 2 belongs to R? Yes. Why? As 3 is greater than 2. X greater than y condition is satisfied over here, so 3 comma 2 is possible. Is 3 comma 4 possible? No. Why? As 3 is less than 4, so x greater than y condition fails here, right? So we cannot take a arrow from here. Similarly 3 6 is also not possible and 3 8 is also not possible, right? Can we take 5 comma 2? Yes, we can take 5 comma 2. See over here, as 5 is greater than 2. Similarly, can we take 5 comma 4? Yes, we can take 5 comma 4 as 5 is greater than 4, which satisfies this condition, right? So basically we will have R as the first element as 3 comma 2, then 5 comma 2, 5 comma 4. Next, is 5 6 possible? No, as 5 is not greater than 6. This is the symbol for not greater than, right? So 5 6 is not possible, so any pair with 5 is now not possible. Similarly, can we take 7 2? Yes, as 7 is greater than 2. Now can we take 7 6? Yes. Why? As 7 is greater than 6. Can we take 7 8? No, as 7 is less than 8. So this forms our answer. This forms our answer, as R as the set of ordered pair is this. Similarly, this is our R: 3 comma 2, 5 2, 5 4, 7 2, 7 4 and 7 6. Now how to find the domain and range of this relation R? Now domain of R, by the definition we have learned that the set of all first components. So 3 5 7 is the domain of R, and range of R is the set of all second components 2 4 and 6, right? You can clearly see here that the domain of R is again a subset of A, and the range of R is again a subset of B. we have discussed. If asked about the codomain, codomain is always the set B, which is 2, 4 and 6, 8. I hope this lecture is clear to all of you. If you have doubt, you can comment in the comment section. Next class we are going to discuss the inverse of the relation, and then we will solve some questions. Thank you for watching my videos. Thank you all of you.